screencast will be about sampling. Sampling is based on the idea that in research it's just not practical to collect data from every single individual in the United States and territories. We're just too big a country. So we address this problem by picking a specific group of people to collect data from, called the sample, and we pick them very specifically and very conscientiously. This process of determining who we'll collect data from is called sampling. Sampling relates to external validity, which we talked about a little bit in the screencast on bias. It's also called generalizability. The technical definition of external validity is the extent to which a study's findings are applicable to or relevant to a group outside of the study. So in other words, this looks at how well the study's findings, what you learned in the study, apply to people outside of the small group of people who participated in the study. And this is important for your annotated bibliography assignment, in that I've been encouraging you to pick a very specific population, specific to the level of 25 individual children with developmental disabilities who are enrolled in your school, receiving services from your program in Allston, Massachusetts, a neighborhood of Boston, who are in 3rd to 5th grade and who speak English as a second language. So it's highly unlikely that you would ever find a study using exactly that population. It's just too specific. But what you are looking at is studies that compare or that evaluate the relationship between two variables. So let's say your intervention was cognitive behavioral therapy, and you were reading a study that was done in Iowa among a group of 100 kids with developmental disabilities, and looked at whether cognitive behavioral therapy, the independent variable, impacted academic performance, the dependent variable. And so you would look within the methods of that study and how those 100 kids in the Iowa study were selected to evaluate whether this study's findings about the relationship between hours of cognitive behavioral therapy received and academic performance might also hold true for the children in your program. One thing to keep in mind as you look at external validity is it's about the study itself. It's not about how closely that population in Iowa matches your kids in Allston. However, evaluating some of the findings, like, for example, if the Iowa study found that it was really important to provide transportation to the kids for the program to work, you might look at the generalizability of that finding. So that's a great finding for a rural community with not much public transportation, which I'm assuming is true of Iowa, though I've never been there. And that might not be true at all of Allston. So that finding about transportation being important to program success might not generalize to your kids who live next to 2 or 3 branches of the Green Line and in the city with a lot of buses and other means of public transportation. But the overall findings about the relationship between cognitive behavioral therapy and academic performance might absolutely be generalizable to your population. And one way of maximizing external validity or generalizability is sampling. So sampling is the process of selecting the people who will actually participate in your study or the people you will actually collect data from. And to do that, we start at the level of the population. So we clearly define the population. To give you a zombie example, let's say I was doing a study where I wanted to survey zombies to find out whether whether teaching zombies how to meditate can reduce the likelihood of zombie attacks. So my population would be every individual who identifies as undead within Massachusetts. This is the set of all members of a group from which a sample can be selected. Going from my population, I would narrow it down to a sampling frame by identifying what are called inclusion criteria. So inclusion criteria are other characteristics that people need to have in order to participate in the study. So one of them is always consenting to participate in the study. If a person doesn't consent to participate in the study, they're not included in the sample frame. And let's say I had some additional characteristics too. So for example, because we're a monolingual research team and our meditation CDs are not available in multiple languages, we can only collect data from zombies who speak English well enough to answer survey questions. And our Institutional Review Board, or IRB, has additional requirements for enrolling children and adolescents. So we make the determination that we are only going to include zombies who are over age 18. And then if I'm concerned about the safety of my research team, I might further exclude zombies who've attacked more than 3 people in the last year, because I want to ensure that my data collection team is safe. So we've gone from the population, every zombie in Massachusetts, to a narrower sampling frame, which is people who, undead people, members of the population, who meet our inclusion criteria. So our sampling frame in this case is undead individuals in Massachusetts who meet the additional inclusion criteria of consenting to participate, speaking English well enough to participate in the study and answer survey questions, having attacked less than 3 people in the last year, and being over 18. And from within that sampling frame, we'll then select a sample. So the sample is the group who are actually selected. So let's say there were 5,000 zombies in Massachusetts. So that's 5,000 people in my population. Once I apply those additional selection criteria of my sampling frame, being over 18, speaking English well enough to participate, and less than 3 attacks per year, say that's 3,000 people who meet my inclusion criteria and are present in my sampling frame. And then I would select 300 people to collect data from, because it's not feasible, say, to collect data from 3,000 people or undead individuals with the amount of money I have to do this study. It should be noted, too, that the sample is the people who actually enroll. So if I approach you, and if you are a member of the population, you meet the selection criteria for the inclusion criteria for falling in my sampling frame, and I approach you and you say you don't want to participate, you're not a member of my sample. My sample is the smaller group of people who I actually collect data from. One thing we think about in the sampling world is the concept of representativeness, or the idea that the 300 zombies I select actually represent the population of zombies, in that they have about the same demographic makeup, the same age ranges, they match on basic characteristics. So if I ended up with my 300 zombie sample and every zombie in that sample was white, my sample would not represent the zombie population of Massachusetts, which is much more diverse. Larger samples tend to be more representative, in that if your sample is 10 people and one person is very different from the norm, that person is still 10% of the sample. So it ends up looking like 10% of people disagree with this one person's very far outside the norm opinions. Whereas if you have 100 people or 1,000 people, that one person or outlier, someone who falls away from the norm, their answers count for a lot less, they carry less weight. And random sampling is also thought to increase representativeness, in that everyone has an equal chance of being picked. So they're more likely to represent the entire population than if I selected people using some other method. And we'll talk about that a little bit more in a minute. So probability sampling is also called random sampling, and it's using sampling techniques so that everyone in the population has an equal chance of being selected. or being invited to participate. So there's various methods, such as randomly assigning everyone a number, and then picking numbers of people to include from a hat. There's computer programs that are random number generators, so everyone is assigned a number randomly by the computer, and then people who were assigned a number, say, over 500, are invited to participate, and people assigned a number below 500 are not invited to participate. The computer assigning numbers randomly. Flipping a coin to determine if someone will be invited to participate is an example of random sampling. It's important to note that random sampling is different from random assignment. Random sampling has to do with the likelihood of being invited to participate in the study at all. Random assignment is once you've been invited to participate in the study and you consent, you're randomly assigned to groups. So someone flips a coin and says, okay, it was heads, you're in the intervention group, or it was tails, you're in the control group. Random assignment has to do with once you're already in the study. Random sampling, a random selection, has to do with who's invited to the study in the first place. So there's several different types of random sampling. So what I was just describing about flipping a coin, or using a random number generator to assign everyone a number and people over a certain number are invited, that's simple random sampling. Systematic random sampling is when we're still selecting people at random, but we're using some system like every fifth person in a phone book receives a call inviting them to participate. Two kinds of random sampling that group individuals and then pick from within those groups are stratified random sampling and cluster sampling. Stratified random sampling means researchers group people by a characteristic of interest. So if I was interested in gender differences, I would group all people who identify as male, all people who identify as female, and all people who identify as non-binary, and all people who identify in another way. So I would have 4 groups, and then I would randomly select people from within each group. So I would within the group of people who identify as male, I would randomly select from that strata or group and invite some men to participate. Cluster sampling is a similar principle, but it's using groupings that already exist. Such as, the floors of a hospital, or if you're doing a study at an agency where there are 5 case managers, and so people are already clustered into groups based on which of the 5 case managers they have, and then you randomly select 5 people from each case manager's caseload. You're randomly selecting from within a grouping that's already been made. Whereas in stratified random sampling, the researcher's making the group in that I'm the one determining that gender is the strata or groupings that I will be looking at and selecting from within. And with stratified random sampling and cluster sampling, it's important to think about intersectionality here. So if I'm grouping people by race, and selecting randomly from within the racial groups I've made, there's a power issue in that I'm making those groups, and is it really up to me to determine? And then there's also an issue in that people have many different identities within the same person. So if I'm stratifying by race and stratifying by disability, by whether or not someone has a disability, I'm making the assumption that people of color and disabled people are somehow different when we know there's plenty of people of color with disabilities, as there are plenty of white people and people of every race with disabilities. So by kind of divorcing 2 characteristics from each other and placing people in stratas or groups, I might be missing some very important intersections of people's identities, and I might be marginalizing people. So if I'm assuming that people of color go in one group and disabled people go in another group, who am I marginalizing? How am I marginalizing, for example, disabled people of color? So again, thinking about intersectionality is important. Sampling error is the technical name for when the sample doesn't match the population. And this is only an issue in non-random sampling. Sorry, in random sampling. In non-random sampling, we don't have the expectation that the sample would match the population. But sampling error occurs in random samples when the sample does not match the population. So in other words, if those 300 undead individuals I'm collecting data from are somehow very different from the overall population of 5,000 zombies in Massachusetts. Again, this is more likely to occur in small samples where one individual could be, 5% or 10% of the entire sample. And so their data is weighed more heavily than if there were more people. Selection bias is a kind of sampling error. We talked about it in the bias screencast. And it's when something is categorically different about the people who were included in the sample. So the example I talked about in the bias screencast was if I was doing a study of access to contraception or experiences with contraception, and I was sampling randomly calling every fifth person who is registered at a clinic using medical records to randomly select people by medical record number. There would still be selection bias at play because people who see doctors are likely to be different from people who don't, and likely to have different contraception needs than people who don't have access to see doctors regularly. And that's an example of selection bias, where causing my sample, my people I call and who participate in my study, to not match the overall population of people who want to access contraception. Selection bias is often present in the study design. So if our study design is that we randomly call various landline phones, or our study is designed to be done online, we're categorically only including people who have landline phones and access to the internet. And that might not be represented